Hello everyone, and welcome back to our fun little classroom on the radio. I'm your host, ichino-ani. I am so excited to dive into another fascinating lesson with all of you today. Today's Monday, July 13th, 2026, and I have a really amazing topic to share with you all. Are you ready to put on your thinking caps? Now today we're looking into the wonderful world of machine learning, and specifically, how artificial intelligence listens to music. The title of the paper we're looking at today is called MulTTiPop, a multitrack transcription dataset for pop music, and the parole for this paper is chips://talkslove.org/abs/2607.8756. Yes, that is quite a mouthful. But I promise the ideas inside are super exciting. So what is the big problem this paper is trying to solve? Imagine you're listening to your absolute favorite pop song on the radio. You can probably hear the singer singing, the drums beating a cool rhythm, maybe a sparkly synthesizer, and a deep bass guitar thumping away in the background. As humans, we can naturally tell all these sounds apart. But for a computer, this is like listening to a giant, messy soup of noise. Right now, scientists have built AI models that are pretty good at writing down sheet music if they're only listening to one instrument, like a solo piano playing a beautiful classical piece. But when it comes to real-world pop music, with all its loud layered instruments and commercial production tricks, the AI gets completely confused and jumbles everything up. The problem is that the computer models simply do not have a good textbook to learn from. The older textbooks, or datasets, as scientists call them, usually only feature classical music, where they use fake robotic synthesizer sounds that do not sound like real human musicians at all. Some datasets do of real pop music, but they only teach the computer how to find the main melody, ignoring all the other wonderful instruments playing in the background. Well, brilliant researchers at Carnegie Mellon University decided to fix this big problem. They created MulTTiPop, which is a brand new dataset designed to be the ultimate textbook for teaching AI how to transcribe multitrack pop music. They gathered 572 segments of real, commercially produced pop music from YouTube, spanning all the way from the 1930s to the 2000s. Then, they matched these real audio clips with highly detailed MIDI files. A MIDI file is basically digital sheet music that tells a computer exactly what note to play, when to play it, and on what instrument. To make this work, they had to be very clever. They used computer algorithms to match the song titles and artists, and then used a special beat tracking method to gently stretch and squeeze digital sheet music, so that it perfectly matched the tiny changes in tempo of the real human performance. Finally, they even had real human students check the work to make sure the digital notes lined up perfectly with the YouTube audio, and they tested some of the best AI models in the world on this new MulTTiPop dataset. The models did not do very well at all. The very best model only achieved 38% accuracy in finding the right notes and instruments. This shows us that there is a huge amount of room for improvement, and MulTTiPop is going to be the perfect challenge to help scientists build smarter AI in the future. Now, you might be wondering, how does this technology actually help us in our everyday lives? Let me give you 3 really cool examples of how this could change the world. First, think about music education and learning to play an instrument. If an AI can perfectly listen to any pop sound and write down the exact notes for every single instrument, it would make learning music so much easier for kids and adults everywhere. Imagine you hear a brand new song on the radio, and you really want to learn how to play that exact drum beat or that specific guitar solo. Instead of searching the internet for sheet music that might not even exist, the AI could instantly generate the perfect sheet music just for you. You could see exactly what the bass player is doing and what the keyboard player is doing, helping you learn and practice your favorite songs almost instantly. Second, this technology would be absolutely amazing for music production and mixing. Music producers love to take old songs and give them a fresh new twist, but it is really hard to separate all the instruments once they are mixed together into one audio file. With a super smart AI trained on MulTTiPop, a producer could feed an old pop song into the computer, and the AI would give them the digital MIDI notes for every single part. The producer could then take the exact melody the singer sang, and easily have a computer synthesizer play those exact same notes instead. Or they could take a classic bass line from the 1970s and completely change the sound of the instrument to make a futuristic dance track. It gives artists a magical tool to take apart a song like puzzle pieces and put it back together in totally new and creative ways. Third, think about preserving music history and helping with copyright protection. Every day, thousands of new songs are uploaded to the internet. And sometimes artists accidentally write a melody that sounds exactly like a famous song from 30 years ago. If we have AI that can perfectly transcribe the multitrack details of every song ever recorded, we could build a massive, searchable library of musical DNA. If someone claims that a new hit song stole their guitar riff, the computer could instantly compare the digital transcriptions and see exactly how similar we really are. This helps protect artists and ensures that everyone gets the proper credit for their hard work and creativity. When we compare this new MulTTiPop dataset to older technologies, the difference is truly like night and day. For example, an older dataset called Maestro is very famous. It only contains solo classical piano music. That is like trying to learn how to paint a colorful jungle by only using a gray pencil. Another dataset called SLEP 100 has lots of different instruments, but all the audio is synthesized by a computer, which means it sounds flat and robotic. Real pop music is singers with unique voices, guitars playing through messy distortion pedals, and drummers hitting cymbals with different amounts of force. By bringing real, messy, beautiful commercial pop music into the training room, MulTTiPop forces the AI to learn how to hear the world the same way we do. It is a big, difficult challenge, but it is exactly what we need to make you hearers truly understand the magic of music. Oh, we have learned so much today. It is so wonderful to see how computer scientists are working hard to bridge the gap between cold algorithms and the deeply emotional world of popular music. I hope that you enjoyed the lesson. And maybe the next time you listen to your favorite song, we'll try to listen really closely to every single instrument, just like our AI friends are learning to do. Thank you so much for joining me in our radio classroom today. Have a fantastic day, and keep exploring the wonderful world of science and music. Goodbye, everyone.